Hi friend, welcome again. Today we will discuss about class A amplifier. In our previous lecture we have discussed only that what is the amplifier and the classification of the amplifier on the basis of different kinds. In previous lecture also we have discussed the classification of amplifier made with the help of transistor, class A amplifier, class B amplifier, class AB amplifier and class C amplifier. Now we will start our discussion with the class of the transistor amplifier. Before going to discuss about class AB and class C amplifier, we will discuss about the quiescent point of the transistor. We have selected operating point during the biasing of the transistor. Now, on the selection of the biasing or quiescent point for using as an amplifier, the transistor amplifier is classified in class A, class B, class AB and class C type of amplifier. So, let's see that here we have used a common emitter transistor for making an amplifier. In this case, we have drawn the output characteristic with its corresponding DC load line. In that case, we are saying that the load line or operating point on the DC load line, the operating point Q is fixed in the mid of its DC load line. So, for variation in input or input is VCE in bold and here the current is IC in milliampere. Now, the response output signal will be in complete form. This is its cutoff region and the input signal provided for the transistor is in its complete form. So, from here if we are comparing the magnitude of input and output variations, then there is no much difference in the amplitude of input signal and in amplitude of output signal. So, the efficiency of this kind of amplifier is too much less. So, we can write down the quiescent point for the Q point for class A amplifier corresponded to the midpoint of DC load line. Such type of amplifier give the voltage amplification without distortion. It means that this is used for voltage amplification in voltage amplification there is less distortion. These kind of amplifier are used for radio and audio frequency signal. That's mean class A amplifier is used in radio and audio frequency amplification. The amplification of an AC input signal by class A amplifier is shown in this figure. So there is less variation in input and output. Here it is providing the current. See, when we have considered the maximum and minimum value of the current, in that case quiescent point is in mid, so we will get a complete cycle of in IC. That's when there is no restriction on collector current, so collector current will always flow. In case of no input signal, IC is high. In no signal condition, collector current IC is maximum, so in no signal condition power drop is high. See, if the input is 0 volt, in that case collector current will be maximum, and in no signal condition the power drop will be maximum. The amplification given by the amplifier is maximum and there is no distortion. However, the frequency, output power and the frequency is low. It means that power output is less and frequency is also low, and power dissipation in no signal condition is too much burst condition for this amplifier. Now we will discuss about class B amplifier. See, in case of class B amplifier, class B amplifier, here from the graph we are observing that quiescent point, as an operating point, is in the cutoff region. When cutoff quiescent point is in cutoff region, in that case there will be no collector current during half input cycle. Only we will get the current for this region, only for positive, not in negative region. So as in class A amplifier, the power drop at no signal condition will be removed. So we can say that the quiescent point in class B amplifier is the cutoff point on DC load line. On DC load line. Here we have selected the quiescent point at the cutoff point on the DC load line. So we are getting only IC 0 to pi, but pi to 2 pi IC is not present in our amplifier. While we are providing the input for complete cycle, we are getting the output for complete half cycle. In this case, the half cycle will be restricted, only we will get the output signal for the half of the input signal. The efficiency of class B amplifier is 50 to 60%. And class B amplifier is used in audio signal amplification, in which distortion can be tolerated. Distortion can be tolerated. In class A amplifier, efficiency is nearly 25%, and in class B amplifier the efficiency is from 60 to 50%, and it's respond only for the half input of the signal, and its quiescent point is at the cutoff point, and also it gives the collector current for 0 to pi, and other half cycle is restricted. In case of class B amplifier we will use for the amplification of audio signal in which the distortion can be tolerated. Now our next point is to discuss about class AB amplifier. So for discussing the class AB amplifier, we will get some similarity with the class A and class B amplifier. See, in case of class A amplifier, the quiescent point is selected in the mid of the DC load line, and in class B amplifier, the quiescent point is selected at the cutoff point. So, in class AB amplifier, the quiescent point will be nearly to the cutoff region, but not on the cutoff. So here we have selected the quiescent point at the cutoff region, but not in actual at the cutoff, and this is our input signal variation. And when we are considering the current for this IC, in that case we will get that the current will be from greater than 0 to 2 pi, 0 to pi, but less than 0 to 2 pi. Here IC current will be increases, and again it will decrease, and in negative half we will get only a particular cycle of the IC, and other will be restricted. And same in the case of input signal also, some part of the input is restricted, while this part only allowed to input. So response is for greater than 0 to pi, but less than 0 to 2 pi. Now in class AB amplifier, Q point is near cut off point on DC load line, but not at the cutoff point. We get response for greater than half cycle, but not for complete cycle. It means we are getting response greater than 0 to pi, but not completely for 0 to 2 pi. The quiescent point is near the cutoff point. We will say that this is lie near active region. This will lie at active region. Class AB amplifier produces low distortions with medium output power with medium output power with high efficiency. The efficiency of such amplifier is between class A and B amplifier, class A amplifier and class B amplifier, and these amplifiers are used in loudspeaker stage of radio receiver, used in loudspeaker stage of radio receivers. So, quiescent point lie in the active region near the cutoff point, and the response is for greater than the half cycle. That means it responds for greater than 0 to pi. And in class AB amplifier, it will produces medium output power with the high efficiency. Its efficiency lie between class A amplifier and class B amplifier, and this is used in loudspeaker stage of radio receivers. Now, our next term is class C amplifier. So, in class C amplifier, the quiescent point is below the cutoff region. The quiescent point is in the cutoff region but near the cutoff point. See here, this is your quiescent point. So, the response will be only for these parts of the input. And this is its output response. While in current response, there will be only less than half for the collector current. IC will flow only for the less than the half of the input and only one direction. Here also we are seeing that for the input condition and the output signal less than the 180 degree. That's when it is responding for 0 to less than 0 to 180 degree. So the quiescent point Q point is in the cutoff region but near the cut-off point. Collector current will flow less than 0 to pi. So average collector current is very small. Average collector current IC is very small. So power drop is also small. So the efficiency of class C amplifier is nearly 75%, and it is used in tuned or LC circuit which is also known as tank circuit in radio and television transmitters. In radio and television transmitters. These amplifiers are used only in the radio frequency stage of transmission and we cannot use anywhere. Now see the conclusion of the types of the amplifier. Here D to D type of amplifier are also mentioned for the graph, but we will not consider these kind of amplifier. We are dealing with the only class A, class AB, class B and class C amplifier. So the efficiency is nearly 25% for the class A amplifier and it will respond for 0 to 360 degree. That's why it will completely respond for 360 degree. When we have considered the class AB amplifier, in that case its efficiency is less than 50% and it is in between to class A and class B amplifier, while its output is greater than 80 degree but less than 360, so we can say that nearly 270 degree. Now class B amplifier responds only for 180 degree and its efficiency is nearly 50 to 60%, and in case of class C amplifier its efficiency is nearly 75% while it's responding to 90 degree, or we can say that 0 to less than 0 to 180 degree. So we have discussed in this lecture about the types of transistor amplifier, in which we have dealt with the class A, class B, class AB, class C amplifier with their efficiency and the discussion on the selection of their operating point. So in our next lecture we will discuss about the common base and common emitter amplifier. Till, thanks to be with me.